So I'm here to demo JSTap. Now this is a tool I've been working on for a little while now. And what it does is it provides a generic JavaScript payload to help red teamers attack web apps. Now, I say red teamers and not pen testers because application pen testers, when we are working with weaponized JavaScript, these are typically custom payloads, okay? We are targeting very specific functionality at clients' apps so that we can demonstrate maximum potential impact. But developing those custom payloads is really easy in the context of a pen test, and not so much for the red team. So but we'll cover that on a little bit of background, and then we'll jump into some demo. First off, my name is Kirkpatrick. You can find me online at all the usual spots as Whodoer, and I'm a senior security consultant at TrustedSec with my colleagues here. And we're a cybersecurity consulting firm based out of Ohio. We kind of hit all the major cybersecurity consulting areas these days. This is the obligatory slide. Our sales rep is here. She would be kicking me in the shins if I did not put this up. So it was up, I had to do this. But the team has really grown over the years, and we kind of hit all the areas. Now, unsurprisingly, given this talk, I am a pen tester in our applications group. That means I spend my days reverse engineering mobile apps, desktop apps, pen testing those, and we certainly do an awful lot of web application pen tests. It is a very common engagement for us. Now, because of that work, my colleagues and myself, we spend an awful lot of time with JavaScript. We are analyzing how developers use it in their applications, but we're also writing a good deal of our own in weaponized payloads, in Frida scripts, things like this. Now, because I have been writing malicious JavaScript for many years now, I am always on the hunt for new evil things I can do with it to kind of keep things interesting. And I have always enjoyed sharing those techniques in talks like this and blogs and webinars, but certainly with my colleagues who over the years have truly grown to really relish the never-ending supply of stupid JavaScript party tricks. Now, before we continue, I want to make really clear from the outset that the sheer joy I get from the shenanigans I get into with JavaScript do not reflect my thoughts on the language itself. As someone who's spent most of their career working as a computer scientist, I think the JavaScript programming language is hot flaming garbage. But it is pervasive hot flaming garbage, and like my kids' pop music, it permeates my life. So, when we are doing an application pen test, for a little bit of background, so we can compare this with red teaming, first, of course, we're doing breadth of coverage. We're looking for vulnerabilities, misconfigurations across the entirety of that app. But a good pen test is going to look to demonstrate depth of impact. And I don't mean severity ratings on individual findings. I mean the development of a proof of concept that draws upon the vulnerabilities, the configurations, and the features of that application, and we chain those together into realistic attacks so that our clients understand, given their current application security posture, precisely what attackers could and would do, and what are the outcomes of those attacks. Now, when we are developing these proof of concepts, it is very common for the last step in that attack chain to be the ability to introduce our own JavaScript into the application. I can assure you we still see all classes of vulnerabilities, but it is common to find some way to sneak our own JavaScript into an app as an attacker. And when you are talking about an authenticated application that has sensitive data and functions in it, like we see in enterprise environments, this can be a Mortal Kombat fatality because we can compromise that data and those functions with just a couple lines of JavaScript, okay? Now, I know a lot of pen testers for a vulnerability such as cross-site scripting, which lets attackers inject their own JavaScript in the app, which ends up running in the browser of users. As a proof of concept, they write JavaScript that pops open an alert box, and they call it a day. I'm not gonna lie to you, I'm not a fan, because while that demonstrates that JavaScript ran, it doesn't demonstrate impact at all, because absolutely no attacker is gonna pop open an alert box. I find that developers, even ones that write JavaScript, often have a hard time bridging the gap in their mind as to what an attacker would do with that same capability in their application. And that's okay, because it's not their job to think like attackers, But as the offensive team, that is precisely our job, and we should be showing them what attackers would be doing with realistic proof of concepts, okay? When you do these demos of realistic proof of concepts with the dev team, it often makes them very nervous. But for a brief window in time, you have their attention. And those demonstrations are often followed by very productive conversations about them asking questions about the real security implications of their design choices and the vulnerabilities in their applications. For an application pen test, in my opinion, these conversations are the absolute best outcome of a pen test. This is much better than my client playing whack-a-mole with findings in a report. They're going to get the report anyways. They can whack-a-mole to their heart's content. But those conversations are absolutely golden. And unfortunately, as an outside consultant, I often don't get the opportunity to have those conversations unless I show up to the table with a little bit of shock and awe. All right? Now, let me see. I want to point out, though, that I'm talking about a pen test, okay? And our ability to write these absolutely devastating payloads that grab the crown jewels of that application and runs for the hills, we had a lot of help getting here, okay? My client has given me credentials to the application, and usually at multiple users, and I've used them. I've mapped out all the functionality of that application. I've studied how the workflows of the different user roles intersect with each other, which means that by the time I find a way to inject my own JavaScript into the application, I already know exactly the sequence of requests to responses that has to flow from the browser to the server and back, and from what user role to achieve some malicious goal. Maybe I want to privilege escalate my account or add a new admin user I control. My personal favorite is downloading data I don't have access to. I love stealing stuff. Whatever that attack is, I know how to do it because it's right in front of me in my burp proxy history, right? Writing a couple lines of JavaScript to juggle those requests and responses is really easy. This is a very simple language, right? For my demo, I don't have to social engineer anyone. If I have this devastating payload that if an admin user clicks this malicious link while they happen to be logged into the app, something terrible happens. For my demo, I play the role of victim. With the devs watching, I log into a test admin account and I click the malicious link. And whatever page pops open where my payload runs, I leave it open long enough for the payload to finish. Although these tailored payloads are usually really quick. Now, that is a lot of obstacles to practical exploitation, right? And while those are interesting discussion points in a demonstration, and they're elements that increase the attack complexity in a finding in a pen test report, these are real obstacles to the red team, right? Identifying a user to target that has the right user role and catching them logged in is not a trivial challenge. And the red team may not know anything about the application. Could be custom. So there's no inside knowledge to even write the weaponized payload to begin with. So I wrote JSTap for this use case. JSTap does not need the user to be logged in when they run the payload. Matter of fact, we flip the script. It's better if they're not. And because we are assuming no knowledge of the application, JSTap doesn't send any malicious requests to the server because we don't know what to send. Instead, JSTap attacks the client side. It instruments the client side of the application in a user's browser very heavily. And when you see this loot we're able to extract from that, I think the value to the red team should become a little clearer. Now, before we jump down to demo, I want to talk about the payload, okay? The JSTap payload has two modes of operation, okay? This first is trap mode and implant mode. Now, trap mode is the original concept behind the tool, and this is typically the mode you would use as a cross-site scripting payload. The past few months, demoing this tool with red teamers, there was a strong desire for a second use case, and that was as a post-exploitation implant. So how that would work, as an example, let's say the red team has popped a shell on the application server, or the server hosting the JavaScript files for the application, or whatever method they use. They're pretty sneaky. They just take the payload and they add it to the application. This is a really nice approach because now every user of the application is going to be running that payload. That's a lot of loot. The other benefit is if you add the payload to, say, a JavaScript file that is used throughout the application, you're going to have persistence of execution. No matter where the user is in the app, they're going to be running the payload, and you're going to have coverage. You're going to have insights as to what was going on. So that's implant mode. Some examples of perhaps the right JavaScript file. Developers often have jQuery. We see it all the time. It's everywhere. Add it to jQuery. Developers often have main.js they throw all their custom JavaScript into. That might be a good one. It depends on the app. If you are in a hurry and you're lazy and have no self-respect, you can add the payload to every single JavaScript file of the application. That is gross. Don't do that. But it's really effective. So yeah, implant mode. Trap mode has a different challenge. When you are attacking a cross-site scripting vulnerability, you cannot assume persistence of execution. As an example, if I have a reflected cross-site scripting vulnerability, there's some page in the app that I can craft a malicious link to this page. And if a user clicks that link, when that page opens in their browser, my payload is going to run. Yes. Now, I don't control, as an attacker, what page has that vulnerability. It may not be an interesting page at all. They may see it, close the browser tab, or navigate somewhere else, and the payload's gone. Now, if I have a tailored payload, that's probably fine. I may have only needed half a second to achieve my goal. But JSTap has to keep running, or you won't get anything. You don't tap a phone line for a second, you won't get any actionable intel. So in trap mode, JSTap brings its persistence with it, with a technique I call an iframe trap. That persistence is probably too strong of a word. It greatly extends the runtime. If you close the browser, reboot, it's gone. But this will keep it running. The way this works, for a little background, an iframe. It's a really old web programming technique, and it's basically a browser in a browser, right? If I'm a web developer, I'm laying out my page, and part of that page, I create an iframe. I point that iframe at some URL, and if the website I'm trying to load allows it, it will show up there as if it's part of my app. And this is commonly used for embedding maps and party credit card payment forms, all sorts of stuff. The problem with iframes is that there's a class of vulnerabilities called clickjacking, all right? If I can frame your application in my site, and maybe I make a game, users are clicking around, and I trick a logged in user into visiting my site, I can make that iframe invisible. I can move it around. I can capture their mouse clicks and potentially execute actions in your app as them. These are clunky to exploit, but it does work. Fortunately, the protection against this is really easy. Don't let your site be iframed. Simple security headers will block this. Content security policy is one of the best ways of setting this up. The problem with blocking iframing is that developers like to use iframes. So fortunately, there's a happy compromise that we see all the time, and that is an iframing policy that is allowed from same origin or self. That means the application can frame itself, but no other domain can. So you're protected against clickjacking attacks, but the developers can still use iframes, so we see it all the time. This policy, or anything more lenient, allows iframe traps to work, okay? So let's say user has clicked link to a boring page. It opens up. The first thing JSTap does in trap mode is create a full page iframe and sticks the user somewhere else in the application, somewhere more interesting. That has to be configured ahead of time, right? It depends on the app, the pretext of your attack. Now, the problem with that, and this is an example where the iframe is not full screen. You see the pink is the background with the vulnerability, the boring page. And in the iframe, we have loaded the admin login. This is where we're going to start the demo today. The problem here, if you look at the top, is that is not the address of the login page. That is highly suspicious. So now what JSTap starts to do is it monitors where the user is in the iframe, and it spoofs the address bar like this. Now, our ability to spoof the address bar is not a vulnerability of any browser. This is intended functionality. While I cannot change the domain or the IP address, that's a big no-no. Everything below it, the path, I can make say anything I want. If I wanted to throw emojis up there and the lyrics to "never gonna give you up," I can do that. That payload is up, by the way, if you need it. But JSTap instead copies the location of the iframe there and continues to do so. So as the user stays in this iframe trap and moves around, the browser looks completely normal. Everything looks fine. Actuality, they never left the original page with a vulnerability. So the payload keeps running. So let's jump down to demo and see what this looks like. Again, we're going to start with WordPress. This is just a basic deployment with a vulnerable plugin. We will start with the alert box. Copy that in there. And there is our terrifying alert box, seen in pen test reports around the world. We will replace that instead with in the JSTap payload. And you can see it here. JS, that is the payload being served by the JSTap server. And we will click that, and you see we are at the admin login portal, and the address matches. That's the lie. We are still on this page. So let's say our pretext was we identified the admin of this WordPress site. We sent them an email from their boss saying, hey, I need you to log in, make sure we're not running this plugin, and hey, that new admin starts next week. Go ahead and set up their account. So we're going to, this is going to be complicated. Hold on. We're going to log in. Okay. So we're logged into the WordPress dashboard, and my boss supposedly told me to go check out the plugins, so we'll do that. And maybe the one they're concerned about isn't there, but they also told me to go ahead and add the new admin user. Now from this, we can see there's only one user currently. That is the account I'm logged as. And we're going to go ahead and add our new admin user. Give me a second. Okay, so I filled out the required information. The new users log in. We've set them as an administrator, and we're not going to email them. Now, WordPress presents us two choices here. I can manually set a password for this user, but the default is to randomly generate a strong password. And you can see it here. So we'll pretend that I wrote that down to give to the new user who starts next week. And we will add this user. Okay. Now, and we see they're there. Now that should be enough to get us started. We will jump over to JSTap, and we'll log into the portal. And what we see here is we have clients on the left, okay? We see that they were first seen 2 minutes ago. The last update was 19 seconds ago. We get their IP address, OS, and browser. We can add client-specific notes. So if you had a lot of clients and you're reviewing what you've been able to get from them, you can add notes about that client. I can't tell if you can see this on the projector. There's a star and an X here. I can star this client if it's a really interesting one I want to come back to. You can kind of sort and filter this list. And importantly, you can kill their session, okay? When the JSTap payload starts, it reaches out to the server to get a unique identifier, and that is used as a session from that point on. Now, if this client is boring or providing me garbage, I can kill their session, and they will be blocked from submitting any more data to the server. If you have maybe done this as an implant and you're getting completely overwhelmed with clients, or the blue team's found your endpoint and is messing with you, you can actually turn off, not that I would do that to anyone, you can actually turn off all new client sessions. So no one new can establish a session, and then the ones that have already been established will keep going. We'll keep that going for now. So if you select this client, you will get a time series of events that are seen, okay? Now, the URL visited at the top here is bugged. It often says blank. I would fix that, but this is free software. Deal with it. Here we have cookies, okay? Now, the JSTap payload is monitoring cookies, local storage, and session storage in that user's browser on the application side. Now, when it first sees a value there, it will report it. From that point on, it will monitor that value, and if it ever changes, it will tell you the new value. Now, WordPress uses cookies for authentication, but like most apps, they correctly set the HTTP only flag on that session cookie, which tells the browser that JavaScript, which JSTap is written in, cannot read or write that cookie value. So unfortunately, we are not going to be able to steal their session directly from this, okay? A lot of apps don't use cookies, especially APIs. They're sending authorization tokens. Those are typically sent in headers. It's not automatically sent by the browser. So you will get a copy of those when they're stolen from local storage or session storage. We see that they visited the login page, and we are stealing the source code so we can get a copy of the HTML code of every page they visit. It's actually better to just download it, open it in your favorite text editor so you get the color coding. I couldn't get color coding to work well. But we are also getting screenshots, okay? As they go through, you can click on them and blow them up. Now this starting page is not a surprise because that's what we configured as the start page. Going down a little further, obviously they're on the login. We see we're getting user inputs, okay? So JSTap is scraping whatever the user types into this app. And that's why I say it's better we catch them when they're not logged in, because we want the credentials. So I want those credentials. I'm going to save those. Actually, I mistyped those. That's a typo, and you actually see wrong password. So let's not steal that one. Let's get this one. That's the correct password. And we can add that to the client notes. And the username was admin. Very creative. I can't type with one hand, apparently. So we've stolen this user's credentials. It's kind of nice. And clearly they successfully logged. The thing we see is they are staring at the WordPress Admin portal. Now I want to point out, when I logged in as the victim here, I didn't scroll down. I didn't see any of the stuff at the bottom. Because we're stealing all the HTML page, we could render that to a canvas and scrape that to an image. You'll actually get more info than the user probably saw. Unfortunately, this is a slightly newer version of WordPress than I started with. The old one had like log data at the bottom. It was really cool. IP addresses, usernames. So it's worth poking around the screenshots. You never know what you're going to discover. Of course, you can zoom in on this, get a closer look. Going down a little further, we see they visit the plugins page. Again, none of these cookies are going to be interesting with WordPress. We'll see better stuff later. The plugins page, nothing terribly exciting there. We do see versions are off here, so there is an update. A lot of the stuff is easy to enumerate externally anyways. Now it gets a little bit more interesting. We see they're viewing the users page. And obviously I have one admin user here, but you would have an entire list of all the users of the system if this is a more realistic WordPress deployment. So that would be handy. But then the next thing we see is they're going to the new page. And we get, clearly they're starting to add a new user. Now I'm going to take this screenshot, I'm going to pull this off to the side so we can keep an eye on this, okay? And drag this over where we can watch. All right, because the next thing we see is a bunch of user inputs. It's really hard to do with one hand. So we get the login, that's this. There's the email, sorry, I'm making a mess of this. But what we don't have is the password. And we go scroll down, and then the next thing, they're looking at the users list again. And we can see they've added new admin, and they are administrators. So that's very handy, useful information. We'll throw that in the notes. but we don't have the password. Let's take a close look at this screenshot. At the bottom in the password section, there's a button that says generate password, and there's a button that says hide. Now, I know WordPress, you probably know WordPress, but if this is a custom app, I may infer that, hey, it showed them the password right there. Well, if the web page showed them the password, it's in the HTML code, and we have that. So let's go back up to the user form and find where we got the code, user new, and we'll download that. And let's go over here. Okay, this is a big, messy, nasty bit of HTML code. First, we can make sure we're in the right place. Create a brand new user, okay? There's that string, it matches this. So we're looking at the right HTML code. Now, we want to find this, okay? And clearly, if we search for a button with a label, generate password, that's going to get us in the ballpark. So let's search for generate password. There it is. Here is our magic button, and if we start poking around the code, we find this. There is the password to our second admin. So we will copy and paste that out. Go back here and add that to our notes. And save that. So we've now got 2 admin credentials, so that's kind of nice. Now that does cover the bulk of what JSTap is able to do. To pivot to the last part of the demo, I want to point out that WordPress is not representative of a modern web app. It's a CMS. It serves static content like blogs and web pages, and that's great at that. But a lot of modern apps are dynamic. They update in real time. You know, what I see on the page can change without me having to refresh the page or navigate somewhere else. Now, the way web apps are able to do this is with JavaScript. It's precisely why JavaScript was invented. In the background, that JS code is making network calls. It's sending data up to the server in the background. It's retrieving new data from the server. And when it needs to show you something new, it rewrites the HTML code while you're viewing it. Now, credit where it's due, that's pretty slick. And now I have said my one nice thing about JavaScript. Now, JavaScript provides 2 main APIs for making these network calls. Okay, there's the older XHR API, which is short for the elegantly named XML HTTP request, which we'll never say that again, XHR. And the newer Fetch API, okay? Although a lot of developers are using jQuery. jQuery is a library that provides a lot of JavaScript programming features and utilities and networking capabilities. But if you dig under the code of jQuery, underneath it all, it is actually using the XHR API, ultimately, to send data. Now, the JavaScript language has a lot of quirks to it, but there's 2 in particular that are relevant to the next feature set in JSTap. One is that these APIs that are built into JavaScript are presented to developers as if they're normal JavaScript objects, like any other developer-defined object. It's a little strange. And the other is that JavaScript supports monkey patching, which means that JavaScript code can be rewritten at runtime by other JavaScript code, which puts us in the ridiculous situation that something as dumb as a cross-site scripting payload can not only rewrite the client-side logic of your app, it can rewrite the networking stack underpinning it. So we're going to switch apps real quick. Let me close some of these screenshots. All right, let me accept this. All right, now this is a toy app that I wrote that does 3 different ways of doing networking calls. We've got XHR, Fetch, and jQuery rolled into one little app. And it's very simple. Each request is just pulling down a new answer to this question, okay? So XHR is 42, Fetch is Vegemite, of course, and jQuery is a quote from Monty Python. Now, This button injects the JSTap payload, kind of simulating a cross-site scripting exploit. But before we do that, we have to reconfigure the payload. We have a new app. We need to set a new start page for the iframe trap. Okay? Up at the top, there's a init globals function here, and this is the start page for WordPress. And then this one we're going to set to this. This is a single page app. You only have one choice. Don't mess it up. Now, the other things we want to enable here is monkey patch. Okay? When this feature is enabled and JSTap starts, in addition to the trap it sets, the iframe trap, it will seek out the XHR and fetch implementations and modify them. Okay? The one other feature we're going to enable here is this. This is a screenshot after API call. By default, JSTap takes a new screenshot when the path changes, right? The user's gone to a new page. In this page, this app, there is no other page. It stays, so no screenshot, second screenshot is made. Now, this feature says, hey, after an API call, which may have retrieved new data to show, after X milliseconds, go ahead and grab a new screenshot. It's not elegant, but it's effective. So we'll save that. Jump back over here. We'll inject the payload. You see that flash? That's the trap mode taking over and everything reloading. And we'll go ahead and make our XHR call, our fetch call, and our jQuery call. Now, app's still working here. Nothing's broken. That took a lot of work, by the way. We'll go over here, and there's our new client. We will select them. And the first thing we see that's a little bit different is we now have something stolen from local storage. These APIs send, not a very well set, but a secret token as their authorization, and that has to be stored somewhere, and that's typically going to be in local storage. So we are going to snag that, because that would give us access to this API. Now we have same kind of stuff. Obviously, this is a simple page, so the HTML code is not interesting. But we get to here, API events. Okay, let's look at this. At the top, we start seeing the application is starting to set up a new call. And the first thing is set is where it's going. In this case, it's going to /API/XHR answer. And the method is post. This is typically going to be a get or a post. Then we see the headers. Now this one is not interesting, but this here is our authorization header. So we have snagged it off the wire, and we've snagged it out of storage. Now once the application has configured its API call, it's actually going to send packets, right? It's going to send data up to the server and hopefully receive something back. Those are tied together here, so we can see the request body that was sent to the server and whatever came back from the server. In this case, it's just 42 is the answer. It's not a very exciting application. And of course, we have our delayed screenshot that captures the pages have been updated with that data from the server. Going down a little bit more, we get the same kind of data from fetch. The implementation of these modifications is very different, but we're extracting the same data, so we can show it the same way. This call is going to the fetch answer endpoint on the server. We have our authorization header again, and there's our API call. And you can see the answer coming back was Vegemite, and of course, our delayed screenshot shows Vegemite. And then one last thing, we see another XHR call, but if you look at the endpoint, it was going to jQuery answer. This is us intercepting jQuery-based comms by rewriting the underpinning API beneath it. And there's our call. And of course, our screenshot. Now that we've stolen our credentials and our API tokens from all our clients, obviously we only have 2 here, but you can go ahead and export all your notes into a single text file if you want to. If you're going through a lot of clients with different user roles, I think it might be helpful to filter your events, okay? I'm showing you all the events because I'm trying to show this off. You could just cut this down to screenshots if you're going through a lot of clients to try to figure out who's who. Is this an admin? Is this a normal user? WordPress, maybe they're just a publisher, a blog poster, nothing interesting. And if you find someone interesting, maybe expand the events to see if there's something interesting there. That's basically what I have for the first release of JSTap here. Again, this is not really something I'm going to use on a pen test, right? In a pen test, I'm going to write those custom payloads. I'm going to go do the most devastating thing I possibly can. If I had a client pushback on me to write those weaponized payloads based on the amount of inside knowledge I had, I might pull this out. But I've been doing this a long time, and that just doesn't happen very often. And when someone throws a fit, they usually get shouted down by their own team, to be honest with you. I've seen it multiple times. But, could be very useful for maybe the red team. Maybe not something they use on a daily basis, but I did want to give them some capability in this area. Right? There are certainly criminal organizations that target web applications. So this is a nice little payload that could be used a couple different ways. Hopefully get you some creds, help you further your access into the system. Now, before I open up to questions, I've kind of been harshing on alert boxes as a proof of concept for pen testers. I think pen testing should be doing proof of concepts whenever we can. Not only is it entertaining for your brain, but I think it's much more informative to the client, right? I think they learn more about the real impacts of their vulnerabilities and design decisions when they see the actual impact of a realistic attack. And if you are a pen tester and you'd like to learn how to write weaponized JavaScript, I got some resources for you. This YouTube is a webinar I gave a couple years ago. It is on TrustedSec's YouTube page. If you search for popping shells instead of alert boxes, you'll find it. That whole webinar is walking through the dev and debugging process from the perspective of a pen tester. You have that inside knowledge, you have your Burp project file, and it shows how to write that code and gradually makes it more complicated until at the end you're popping a shell. If you like that, I have a free workshop that goes with it. VM you download, it's got the same app, all the tools are pre-configured, all the same code snippets if you just want to copy and paste that over to build up that payload, and a detailed guide so you can kind of try it out for yourself. I have not ported this VM to ARM yet. Sorry, I just got my M2. It's on the list, but those are free. Go give them a try if you want to learn how to write code like this. I can assure you it's very entertaining, despite how bad the language is. But the language is running an interesting place from an attacker's perspective. But with that, I will be quiet and ask if there's any questions. The code is here, JSTap on my GitHub. Here's a couple ways of contacting me. My DMs are open. If you want to reach out, give it a try. If you have any problems, please let me know. Just please don't send me any of your client's data. It's always weird when that happens. But I'm happy to help try to fix bugs if you're having issues. So yeah, anyone have any questions? Yes, sir. So the question was basically how to prevent the iframing, okay? Which of course, for multiple languages. Now, of course, there's always the implant mode. If the red team has found some access, then nothing that you do to stop iframing will stop implant mode, okay? The iframing is only needed to establish persistence as a cross-site scripting payload. Now, there's a couple ways, generic ways of blocking iframing, okay? The best is setting a content security policy. It sounded like you were talking about plugins that you can add maybe to WordPress that do this. Those plugins are doing that. They might also be setting frame options, which is technically deprecated. It will probably still be working when my kids are driving 10 years from now. Web deprecation kind of works like that. It hangs around forever. You can also, OWASP has a really strong JavaScript-based frame buster, okay? I personally hate these as a pen tester because they're hard to identify. I can look at the headers immediately and know if iframing is going to work. But if they, for some reason, went back to JavaScript-based frame busters, I got to go hunt that out. Best to try it and see if it's working or not, okay? The JavaScript frame busters kind of died off for a long time because browsers added these features like XSS Auditor, which was supposed to make cross-site scripting vulnerabilities kind of go away. It was able to identify these payloads and neuter them before they ran. Attackers figured out they could control that, and they could take out the JavaScript-based security controls. So you would actually be able to take out those security controls using security features of the browser. So Google eventually they tried to fix it. It's just a flawed idea. It sounded great on paper. They threw in the towel and ripped it all out. So since that's happened, these past couple years, I've started seeing the JavaScript-based ones kind of come back in favor, but honestly, the headers is the best way. If there's plugins that do it for you in WordPress or whatever your server is, you like proxies, add headers, lots of ways to do it. But the header, I think, is the most secure way. In theory, with JSTap, I'm on the DOM with JavaScript, I might be able to hunt down your JavaScript code doing the frame busting and neutralize it myself, because I've already got my JavaScript in there. It would be hard. I can't do that generically. I thought about it for this. I don't think I could do it generically, but I could write custom code that would do that. Okay, if I found some page of your application that didn't do that, I could load that, hollow it out, and replace the content with the pages I want you to see, right? Basically like web page hollowing. I just need to find one that's not protected, and then I can reuse that as a canvas to do everything else. Yes, sir. So the question was, can I scan a large number of websites trying to determine if they're being protected against iframing? It would be very easy to check for those headers because they're going to be in they should be in every single response from the server if it's done correctly. So all you have to do is get the main page, check the headers, and see if either Xframe options or an appropriate configured CSP. CSP does a lot of things in addition to iframe controls, so you'd need to check that. But it would be very easy to automate that, yes. Anyone else? Going once? Going twice? Okay, well, thank you everyone for coming out.